Okay, now we're going to talk about series and parallel circuits again. Okay, series circuit is one path for current to flow. Parallel circuit has more than one path for current to flow. And a series parallel circuit has a combination of both. Now here's some of the rules on a series circuit you need to understand and you need to remember. A series circuit is defined as a single path for the voltage to flow from beginning to end. There's only one path for that current to be pushed through. Voltage to flow to ground through a resistance. There may be multiple loads. In other words, what it's saying is I can have one load that would go from source voltage, one load to ground. I can have 5 loads, voltage source through the 5 loads and line to ground. There's only one path to ground in a series circuit. There may be multiple loads, resistance, but if the voltage goes through all of them in a single path, then it's a series circuit. All available voltage is used in the series circuit. So as current is going through each load, what this is saying, as current is going through each load, it's going to drop voltage. That drop should equal source voltage. Although if I had 12 volts and two resistors in series, then each are 4 ohms, each one's going to drop 6 volts. When you total it together, it's 12 volt drop. Let's start with 12 volt source. I should have an equal drop across the loads. The same thing on a 3-leg circuit. Same concept. The total resistance of a series circuit is equal to the sum of the resistance of each component, connection wire in that circuit. In other words, if I had 12 volts, 2 resistors in series, 4 and 4. Oh, let me make it even. 12 volts, 2 resistors in series, 2 and 2, and the ground. The 2 resistors in series, 2 and 2, got 12, 2, 2, ground. You add the 2 resistors together, makes a total of 4. So my total resistance is a combination of all the resistors in series. You just add them up. Then you divide the voltage by the resistor to give you the amps. In this case, I would have 3 amps. And as you can do the math, each resistor is going to drop 12 volts. With total drop of 12 volts, not drop 12 volts, probably 6 and 6 again. Because here's another rule you need to remember for the test. If I had 2 resistors in series, and they both the same number, they both equally drop the same voltage. You don't have to do the math. But when that number changes, you got to add them together and do the math. A series circuit is a circuit with only one current path. That means current starts from the battery, goes to ground, flows in one direction, and that's it. There may be multiple loads, but the current flows equally through all of them in a linear fashion. The current flow through a series circuit will be the same throughout the circuit. That means I can check the current in the beginning of my main line or on my ground. It's the same number. In a series circuit, current stays the same through the whole circuit. This means that measurement can be taken anywhere there's a good access on the power or ground side of any loads. Now look at this. This is a simple series circuit. I have my battery, conventional flow, positive and negative, electrical motor force, voltage. It's going to push the current through the conductors, through the switch, through the load resistor to ground. This one load should drop the total voltage from the battery. So if this is a 12 volt battery, that load, if I do a voltage drop across it, should drop 12 volts. My current should be the same here and here in a series circuit. Now I don't know why they call this a voltage drop. Because to me, like a potential voltage or available voltage at certain points. Now look at my meter. Here's 12 volts here, ground. My potential voltage up to the light, it should be 12 because there's no load in front of it. So my voltage coming from the battery through the switch here should be source voltage because there's no load in front of this light. So I should read 12. Now, since this is 6 ohms and this is 6 ohms, my total, like I said earlier, you add them up. That's 12. 12 divided by 12 is 1 amp. So this light, 1 amp times 6 ohms equals a 6 volt drop. Remember, you gotta remember Ohm's law formula. B over A times R. So if this drops 6 volts, what that's telling me is that it's gonna be 6 volts after it's used up here. The remaining is gonna be another 6 volts. So I'm gonna have 6 volts remaining here for the next light in line. So since there's 6 ohms and 1 amp in this circuit, 1 amp, 6 ohms, a 6 volt drop, 6 here and 6 here, 12 volt battery, it used up 12 volts. That means on this end here, I should be near 0. Should be no voltage. It should never be voltage on the ground side. It should be never anything higher than 0.1 on the ground. Now, here's a series circuit again. We're going to do a voltage drop on it. I think doing actual voltage drop this time. Oops, shoot. Let's see. Okay, here's a series circuit going to do a voltage drop. We have 3 resistors in series. 3, 2, and 1. What's my total resistance? Add them together. That's 6. 3, 2, and 1, 5, 6 ohms. My total resistance is 6. 6 ohms divided by 12 volts gives me 2 amps. That means there's 2 amps through the circuit, in the circuit. 2 amps say here and 2 amps going back. Remember, what the amperage that leaves the battery got to return to the battery. So if I had 2 amps here that left, there had to be 2 amps here that goes back. Now since there's a series circuit, because they are all in line to each other, 2 amps will flow through this resistor, through this resistor, through this resistor to ground. The only difference is the voltage drop. If you remember Ohm's law, 2 amps times 3 ohms is 6 volts. 2 amps times 2 ohms is 4 volts. 2 amps times 1 ohm is 2 volts. Add all 3 together, 12 volts, source voltage. And basically what we just did here. So now the 2 amps value can be measured along each resistor value to calculate the voltage drop across each resistor. The voltage drop is still V in Ohm's law, which is calculating the difference in electrical pressure between any 2 points. See, we got voltage equals amps times resistance. Voltage drop equals amps times resistance. And basically what I just showed you earlier. Now this is a voltage drop. As we've seen earlier, it's 2 amps in this circuit. Remember, 3, 5, 6, 12 divided by 6 is 2 amps. Now, let's go through the first one. 2 amps times 3 ohms. It drops 6 volts. When you hear the word drop, think about it used up 6 volts to push the current through it. On this one, remember the same amperage, 2 amps times 2 ohms, 2 volts. 2 amps times 1 ohm, 2 volts. Drop. You add them together, 6, 10, 12. Assuming a 12 volt battery, it dropped all 12 volts. Now, here is a diagram in series. Let me find the right one here. Here's a diagram in series using 3 resistors in series. Now, usually on a car, you don't find too many components in series. But this one you do. It's your blower motor. You got low, medium, and high. Each one's going through a resistor, cutting down the voltage to the blower motor. Here's a great example. I got voltage here, and using the wiring diagram, you start from top to bottom. It's my source. Arrow here says come from the source, which is probably the ignition switch or the battery. My fuse, which is, let's say for the example, is 12 volts. 12 volts going through this fuse and out this wire. Circuit 641 from connector C1, pin A5, brown wire. It's leading right into this HVAC connector, control assembly. But what I want you to look at here is this. Low. You see it here? It says low. So you turn the blower motor to a low speed. You're looking at this, M1. That's position, M1. Now the reason why it's going to move slower, watch how the current is going to flow and the voltage. You can go through this connector here, through this blower motor resistor assembly. The resistors are in series with each other. Going through this one resistor, drop voltage. Going through the next resistor, number 2, drop more voltage. Going this resistor number 3, drop even more voltage. Going through an internal fuse, follow wire the circuit this way, circuit 101. And I might have forgot to tell you earlier, this is a grommet. P200 means grommet location. That P200 is the grommet location. So go through this grommet, the wire is going through a grommet. Going into its HVAC blower relay, going through a switch that's closed, out this terminal B1, going back to another grommet to the motor. Now, right here at terminal, this male connector, terminal B, did you think we still had 12 volts here? Remember, I went through 3 different resistors and dropped the voltage. At this point right here, the increased resistance will cut down the voltage through the load device to ground. And this motor right here will run much slower. I didn't get that out. And this motor here will run much slower, because it had to feed us up to 3 resistors. Let me see something here. As I'm looking at this, I think I made a slight mistake. This low speed right here, we got off low. Low is this way, going through this other resistor. This speed just a slight higher here. They're not low. We're on M1 here. That's another circuit. So on this circuit here, we're going through 1, 2, 3 resistors. So here I will have voltage. I will have less voltage here and less voltage here. And when you get to the motor, it's going to be a little lower, cause the motor to move slower. If I was on this side, low, I will have 4 resistors in series. 1, 2, 3, 4. On the position I have right now, there's only 3 in series. Here, here, and here. So I'm going to have system voltage here. I'm going to have voltage drop here. And then A, I'm going to have less A voltage here. It's going to be much less than C here. Then D going to be less than A and C. And that's how we cut down the voltage down to the motor and make the motor run slower. Anyway, that's an example of a series circuit. Now here's a parallel circuit. In a parallel circuit, you can see how it's hooked up. It's more than one branch. You got the switch going through here, going through this branch, the ground, and going through this branch, the ground. In a parallel circuit, current is not the same. It leaves one number, it splits base cost of resistors, and regains the total value here back to the battery source. Each branch of a parallel circuit is its own series circuit. All the series circuit rules apply to each branch, not the whole circuit, that's the branch. This will have a common power source, or ground, but the resistance of each leg determines the current flow. So based on the resistors you've seen here, based on these resistors here, and here, let's say this is 2 and this is 4. They're gonna pull a different current based off that resistance. That's what it's saying. If this was 2 ohms, it will pull 6 amps. If this was 4 ohms, it will pull 3 amps. It's not a series circuit anymore, it's a parallel circuit. So each leg will draw a certain amount of amperage or different amperage based off its resistance. Let me see, but the resistance of each leg determines the current flow through that circuit without affecting the current flow through other parallel branches. And again, basically, what I'm saying here, if you look at the diagram, if this top light blows out, it will not affect this, and vice versa. The branches do not affect each other unless I have a break here or here. But each individual load, if one goes out, this one will still work. It does not affect this one. They do not affect each other that way. Unlike a series circuit, if one goes out, the whole thing goes down. Voltage drops the same in each branch. I mean, each light, if I do a voltage drop on each light across the load, no breaks in the circuit, or no interruptions in the circuit, I'm going to see source voltage on each leg. Going across the load, on each side of that load, my red lead on the power side, my black on the ground side, on each leg, I should read source voltage. So voltage drop the same on each branch. The voltage drop for each branch equals source voltage. Current flow may vary in each branch, like I told you earlier. There's more than one path for current to flow. Each branch will flow current in proportion to the load in that branch. The total current through a branch circuit is equal to the sum of the current in each branch. The total current is also what you'll measure in the main line feeding the branches. So basically, if this was 4 ohms, this was 2 ohms. This is going to pull, if this was 4, it's going to be pulling 3 amps. If this was 2, it's going to be pulling, did I say 2? 4 and 2, right? So this would be 3 amps, and this would be 6 amps. You can write that down. The total amount of current is going to be the current added with both these branches together. That would be the main line and the feed line. So the total current on both legs, we'll see here and here. But going across each leg, going through this way and this way, the amps will split based off the resistance. Again, that's my main line, individual branches. And again, here it is showing you, I said earlier, you add the current up. If I had 2 amps in this branch, 2 amps in this branch, the total amps that left this battery is 4. So I put an amp meter here, I in series here, I amp meter in series in this switch. I'll put an inductor amp meter here, it'll be 4. I can also measure 4 here. Nope. That's our individual grounds. Let me see, I say that again. Yeah, we'll have 4 amps here. Each branch will have 2 amps going through this leg and 2 amps going through this leg. But my total that left the battery will be 4. But my voltage drops on the parallel legs, 1, 2, 3. Each leg will drop 12 volts in a parallel circuit. This is a parallel circuit. As long as there's no resistance in series to these 3 resistors here, in series I mean up here anywhere, each leg will drop source voltage. My ammeter up here will see the total amount of current on this main line that needs to be fed for the total branches here. In other words, this will take up I got 12 volts, 12 ohms, 1, 1, and 1. My total of 3 amps. My meter here should read 3 amps. But each leg is taking up 1 amp each. And you can see how they hooked up. Red lead on this end, black lead on this end. A voltage drop across that lamp. My amp meter, break the circuit open, it's in series. Now don't get this confused. An amp meter, the circuit has to open up to connect in series. A voltmeter, you do not interrupt the circuit. You do not open up the circuit. You hook up parallel to the circuit, like you see here. Don't get the two confused. You'll get it wrong in the test. Now, I think that's it. If you have any questions, let me know in class. Peace. I'm out.